Hello people, welcome to Science Chomp. Today we're going to be talking about heating curves. This is a heating curve, as you can see on the screen. So let's talk about the features. On the y-axis we have temperature. On the x-axis we have time, although I actually prefer it when it says energy rather than time because it makes it a little bit easier to understand. So exactly what's going on? Well, first of all, we have a solid and we give it a certain amount of energy and it heats up. The reason why it heats up is all of the heat energy that we give it gets converted into kinetic energy, like so. So these particles end up vibrating a little bit more like this. So the more heat you give it, the more it gets converted into kinetic energy, the more that these particles move, and the higher the temperature goes. And the reason why the temperature goes higher is because temperature is the measure of the average kinetic energy of the particles of a substance. So the more you heat something, the faster the particles are moving, and as a result, the hotter it gets. That is until it gets to the melting point. This first bit over here is the melting point. So how come the temperature doesn't rise during the melting point? As you can see, it's completely flat. It's not going higher, it's not going lower, it's just staying the same. Well, the reason for that is instead of the energy being used to make the particles go faster, the energy now is being used to make the particles get further apart. So these things are further apart than they were in the solid. And it can't rise in temperature until all of these particles have separated out and basically formed a liquid. And as a result, this part, the melting point, does not get any hotter. The particles don't have any more kinetic energy, they've just moved a little bit further apart. And that happens until it becomes fully a liquid. And then finally what it can do is it can rise in temperature because all of the energy now, again, as before, is being used to speed up the particles, giving it more kinetic energy. And as we know, as I said before, temperature is the measure of the average kinetic energy of the particles. So the more kinetic energy the particles have, the higher the temperature. So let's write that down. So we're going to call this part 1, and I'm going to call this part 1 as well. And for 1, the energy, the heat energy, is being converted into kinetic energy. And as kinetic energy goes up, the temperature also goes up. And I'm going to call the other part number 2. So this is number 2. And I'm going to call this number 2 as well because the exact same thing happens over there. So on those flat parts, the energy is being converted into potential energy. And as a result, the temperature doesn't go up because the particles are all moving the same speed. And then when it's a gas, as much energy as you put in, it just gets converted into kinetic energy and it just gets hotter and hotter. Now there's another type of question that you may encounter, and that would be a question like this. They'll give you a heating curve, this is for water, and they'll ask you what is the melting point and what is the boiling point. For the first question, what is the melting point, is you find the first plateau, which is here. This is the melting point. They're probably not going to label it like this, but if you're in a lower grade, they might do. And then all you're doing is you're going across, going all the way to the y-axis, and you're reading the number over here, and this will be 0, and we want to give it a unit, and we just take the unit from over here. It's 0 degrees Celsius. And similarly for the boiling point, all we've got to do is we find that second plateau, we go all the way across, find the number on the y-axis, we read it off, and we just write down 100 with the unit degrees Celsius. Hope that makes sense. Thank you very much for watching, and goodbye.